Okay, so this is solving trig equations, and okay, we're not going to take a quiz, okay, because really the quiz would be on the first two lessons that we did before the SOL break. So I'm going to give you the quiz to take home, just to be able to do it with the homework tonight. That'll be a review of those concepts, because you're going to be tested on it next week, one way or the other. So you need to see it, but you don't have to do it in the middle of a quiz that you don't really feel ready for. So that's the plan, right? So that means next class will be the review, and the class after that will be the test on Tuesday. And then we'll still have Thursday and the Monday left to go. Based on that test, some may still decide that they want to take the exam, but everybody is exempt, right? Because you did so well on the SOLs. So, solving trig equations. The variable that we solve for is always part of the angle, which is actually inside the trig function. So before you can solve for that angle, you have to isolate the trig function, right? So that's going to be the first step. Isolate the trig function, whatever it is. Let me undo that. Make that a blue and make it a medium. That's good. Okay, then once you've got it isolated, for example, like sine of theta equals, then how do you get at the theta? You use the inverse trig function. Okay, if the problem says solve it exactly, right, that means the angle is going to be an angle that's on the unit circle. So for example, you would recognize if it said sine of theta equals root 2 over 2, you would say, well, that's a unit circle coordinate. So I need to give an answer which is in terms of pi, right? Not just put it into some decimal, like what's the sine inverse of root 2 over 2, but you need to come up with what is the, in terms of pi, value of that angle. Okay. So keep that in mind. And then the other thing is, because all of the trig functions are periodic, there may be more than one answer. For example, if I said, where does sine of theta equal root 2 over 2? Well, that's here at pi over 4. At least that's one place. But if I go around the circle one more time, I'm back to the same place. So the sine of theta would actually equal root 2 over 2 again. And again, and again, and again, infinitely. So our answers sometimes will be, more than one answer. In fact, this one, besides just the pi over 4, it could have actually been 3 pi over 4. And then for the 3 pi over 4, it repeats every 2 pi around the circle. You've got another answer. So you've got to learn, how do we deal with that? How do we show all the answers? Okay. Good. So here's an example of solving exactly. So the first step is, it's got a sine of x in there. I need to isolate that sine of x. So what should I do first? Add the square root of 3. 2 sine x equals the square root of 3. Okay, and then sine of x equals the square root of 3 over 2. Okay, well, we should recognize that from the unit circle. Okay, so let me see. On the unit circle, the square root of 3 over 2 was the y coordinate here and here, right? And those angles were pi over 3 and 2 pi over 3. Okay, so the way we're going to say it is x equals pi over 3, but then to take into account the fact that actually it'll be at that same angle, it'll be coterminal with that every 2 pi that I go around, then I'm going to add plus n times 2 pi. So that means you get multiples of 2 pi from that pi over 3, which gets you to the same place. So n, a lot of times n is a counting number like 1, 2, 3, but in our case, It's an integer because it could actually be negative. You could go around, clockwise and get back to the same place. So negative angles would be fine. N is an integer. Could be plus, could be minus. And then I got to do the same thing for the 2 pi over 3, right? X equals 2 pi over 3 plus n times 2 pi. That's how you deal with the periodic nature, that it repeats itself over and over and over. Okay. Try this one. Try to solve that exactly. So what did the sign of x equal? Sign of x equals 1/2, right? So obviously you would have subtracted 4 from both sides to get 2 sine x equals 1 and divide by 2. And then you just got to think, okay, where is it that the sign, meaning the y coordinate, equals 1/2? Well, remember, 1/2, whenever you get a 1/2 for one of the coordinates, then the other one is √3 over 2. So it's not like the one that's right in the middle of the quadrant. It's either down here or it's up here. Well, the √3 over 2 is bigger than 1/2. In this case, it looks like that means the x coordinate is √3 over 2. The y coordinate is 1/2. That would put it about right there. And then if it has that value there, it would have the same value there. So this angle is pi over 6. This angle is 5 pi over 6. So those are my answers. X equals pi over 6 plus n times 2 pi. X equals 5 pi over 6 plus n times 2 pi. Sometimes, I'm not sure this book, they may actually write this n times 2 pi like as 2n pi. I've seen them write it different ways. I kind of like saying n times 2 pi. I mean, it's like multiples of 2 pi. Seems to make more sense to me. Okay, so that is a pretty basic. Okay, now we're solving for the theta, or x in this case, in an interval. So it's not going to go on forever. There's just going to be so many values. There may be more than one, but there's not going to be infinitely many values. Because it's, actually, I jumped ahead. It's still the same point. It's only between 0 and 2 pi. And notice that it actually includes 0, but it does not include 2 pi. We know those are actually the same angle. So if we got to that place, we wouldn't give 2 pi as the answer. We would give 0 as the answer. So again, I've got to isolate the trig function, right? Subtract 2. And then divide by 9. Right. And then I got to take the square root of both sides. So that is going to be plus or minus 1/3. Okay, now, this one did not say to solve exactly. Now, that could just be because I forgot to write it in there. But you know what? It can only say that if we got unit circle coordinates here. Does the using all those combinations of x's and y's, is there a way to get tan x equals 1/3? So what we've seen before is, what if the tan of x Okay, thank you. If the tan x equals, let's say, 1 over the square root of 3, then if I divide the numerator and denominator by 2, those would make sense for a y and an x coordinate, right? 1/2 and √3 over 2. But not with the 1/3. So this is not going to be one where we can just go to the unit circle. So let me make two equations out of this. Tan x equals 1/3, and tan x equals negative 1/3. Okay, then how do we solve for the x? Say again? Yeah, use a calculator. I mean, at that point, we're going to have to say x equals the tan inverse using the calculator. Okay. So if you see up here, right, notice that the interval they gave us was in terms of radians. So you should have your calculator in radian mode. Don't get a degree answer for this. Get a radian answer for this. So check the mode, check, and then second, tan inverse 1 divided by 3. I'm getting 0.32. 0.32. What if I do the tan inverse, the negative? Second tan inverse of negative 1 divided by 3. Negative 0.32. Okay, now, negative 0.32 is not between 0 and 2 pi. So that's not going to be a good answer. The 0.32, that should be okay. Now, let's review our unit circle again. In radians. Right, so it starts at 0. It goes to pi over 2, which is 1.57. It goes to pi, which is 3.14. It goes to 3 pi over 2, which is 4.71. And then it goes to 2 pi, which is 6.28. Right, so this 0.32, that would be somewhere between 0 and 1.57, about 1/5 of the way. There's 0.32. Now, we did this stuff when we were doing that section about inverses. How do I find another angle for the tangent that would also have a value of 0.32? Remember, you add pi. It's straight across the circle. So it would be about like right there. So we have to add pi. And that should be 0.32 plus 3.14, which is 3.46. Now, could I add pi one more time to find another angle? If I add pi one more time, I would be greater than 2 pi. So no, it says between 0 and 2 pi, so don't do that. Okay, this negative 0.32, that would have been right there. Okay, so that's not a good answer. But if I add pi, that'll get me straight across the circle to about right there. So that'll be negative 0.32 plus 3.14. 2.82. Right, this is not really an answer, right? We needed it to get started, but actually it's not between 0 and 2 pi. Okay, now we could add pi again, and now we're going to get around to that same place. It's what negative 0.32 was before, but this time it will be between 0 and 2 pi. So add 2 pi again. So this is going to be negative 0.32 plus 2 pi plus 3.14, 5.96. And again, I can't add pi again. That would take me beyond 2 pi. So those are the answers. 1, 2, 3, 4 answers. Okay, so try this one. Now notice this time I used the interval notation, which has got a square bracket on 0, which means 0 is included. And it's got a round parentheses on 2 pi, which means 2 pi is not included. And just to get you started here, because I know this is always one that causes a little bit of trouble the first time you see it. But you've been shown now, right? So cosecant squared is 1 over sine squared. And then I can flip both sides. Sine squared equals 3 over 4. That's what you got to do. Now you keep going. So what do you get when you take the square root of both sides there? The sine of x equals plus or minus the square root of 3 over 2. So there you go. This is going to be a unit circle thing. Square root of 3 over 2. And I can look at this. Where does sine equal either plus or minus square root of 3 over 2? In radians. So again, it's got to be one of those where the coordinates are not equal, and it's got to be where the y-coordinate is actually the bigger of the two. So it should be either up here, or down here, and here. And what are those radian measure angles? Pi over 3, 2 pi over 3. Okay, and at that point it said just between 0 and 2 pi, so are there any others? No? I mean, you don't have to add plus n pi or anything like that. So those are the answers. X equals pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay. Next. Okay, the water depth D for the Bay of Fundy, which I don't even know where that is, can be modeled by, and we get a cosine equation. Okay, so we know about cosines, right? Generally, cosines start at their maximum and they go down from there. But this one's got a negative in front of it, so it's actually starting at its minimum and going up from there. It's been shifted up 35, right? So you can see it has an amplitude of 28, but it's shifted up 35. So it should look something like this, right? If this is 35, and an amplitude of 28, that means it's got to go, what, from 7 to plus 28, 63? And we would expect that it starts at its maximum there, and actually it starts at its minimum, and then it goes up, and it goes down, like that, something like that. Okay, this says D is measured in feet, T is measured in hours, T equals 0 means midnight. At what time is the water depth 7 feet? So what are we supposed to do with that? Yeah, you have to substitute D equals 7 and solve for T. Okay, so we're going to say 7 equals negative 28 cosine of pi over 6.2 times T plus 35. Okay, so now we got to just follow steps. What would we usually say we do to solve a trig equation? First, isolate, okay? So I need to subtract 35 from both sides. That's going to give me negative 28 equals negative 28 cosine of pi over 6.2 T. Okay, now I've got to divide by negative 28, so we're going to get that the cosine of pi over 6.2 T equals 1. Well, now that's a unit circle value. I don't need a calculator for this one. Right, where is it that the cosine equals 1? It's 0, right here, right? That is the place where cosine equals 1. Okay, but now because we don't actually have just a variable inside, you've got this pi over 6.2 times t, you have to set that whole thing equal to 0. Right? So I'm going to say pi over 6.2 t equals 0. Okay, but what if I also said, well, it could also be 2 pi. I mean, if, you know, when is it, what is going to be the value of t if pi over 6.2 t equals 0? T equals 0. So basically that's at midnight, right when it started. It started at its, at the 7 feet. Okay, so we also need to say, okay, what if pi over 6.2 t equals 2 pi? Because that would be the same place, right? So let's see, let's multiply both sides by 6.2 over pi. And then we're going to get t equals 2 pi times 6.2 over pi. And then that, I can cancel the pi's. And so t equals 12.4. So what time is that? Well, it's 12.4. So what's 0.4 times 60 minutes? 24 minutes, right? So it's actually 12:24. Okay, and so, I mean, if I let this go around the circle one more time, right, it's going to be double that, which is going to be beyond the 24-hour day, which means it doesn't look like this thing is repeating itself on a 24-hour cycle. You know, it's a little bit off because of that. And, you know, what makes me wonder is this 6.2 there, I wonder if we put in 6.28, if we made that into 2 pi, then I'll bet you at that point it would actually be 0 and noon and midnight, and it would just keep repeating like that. But it just, you know, by only using 6.2, it looks like it's at 12:24. Okay, so let's try that. Next, solve. Okay, so now we're getting into a problem where we've got to isolate the sign, but the sign is in two different terms. Okay, but that's a problem we've dealt with before. I mean, we dealt with this when we dealt with polynomials. What if this was x to the third minus 4x equals 0, right? The variable's in two different terms. How are you supposed to isolate it? You factor it, right? You have to factor. So that's what you do. In this case here, we've got a factor. What is the common factor between those two terms? There's one sine x, right? So sine x times sine squared x minus 4 equals 0. So you factor it, and now you use zero product property, set each factor equal to 0, right? If sine x equals 0, then what is the value of x? 0, right? On the unit circle, the y-coordinate is 0 right there. Okay, now, they didn't give us an interval, so we have to put in all the values. So that could be 0, but it could also be, actually it could be 0, it could be pi, right? It could be 2 pi, right? Because it doesn't have to go around 2 pi to get that same value. It actually gets a value of 0 at pi. So you could write it like this. You could say x equals 0 plus n times pi. That means don't just go 2 pi, go every pi. And at that point, there's no purpose to have the 0 plus. It's just n times pi. Right, that's the solution that we get from sine of x equals 0. Okay, now let's try the other one. Sine squared x minus 4 equals 0. Now, you could factor that like a difference of squares, sine x plus 2, sine x minus 2, or you could just isolate the sine squared. Sine squared x equals 4. Take the square root of both sides. Sine x equals plus or minus 2. Okay, what does that tell you? Where does sine equal 2 or negative 2? What is the maximum value for sine? It's 1. It never equals 2. Remember? The sine values go from negative 1 to 1, negative 1 to 1. So this is no solution. Remember, the range of the sine function is negative 1 to 1. So the only answer is this one right there. Okay, try this one. Try that one. Right, so if you factor this one, you get the sine x times sine squared minus 1. Okay, you did the sine x on the last slide, so we'll leave it at that, x equals n pi. For this one, sine squared x equals minus 1 equals 0, so sine squared equals 1, so sine of x equals plus or minus 1. Okay, where does sine equal plus and minus 1? Here and here. So how could we say that? Because it's going to keep going on forever, right? It doesn't limit itself. Pi over 2 plus n times pi. Right, that takes you halfway around the circle. Keep going, going, going. Okay. Let's them up. Okay, solve in the interval. This time it's 0 to pi inclusive. So it could be either 0 or pi. And this time, I mean, we just factored on the last two slides. So you might say, well, I guess, you know, could I factor if this thing was x squared minus 5x plus 2? Is that factorable? Are there factors of 2 that add up to negative 5? And the answer is no, it's not. Okay, so if we had to solve this with math, what would we do next? Quadratic formula. Now, you could use that app to do that, right? You could just put it in the app, you know, 1, negative 5, and 2, and it's going to tell you what cosine equals. You'd still have to, like, do the cosine inverse to find what x equals. But you could do it like that, or you could use quadratic formula, right? It's just that now, because it's got cosines in, it's not x equals, it's cosine x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 2 all over 2 times 1. Cosine x equals 5 plus or minus the square root. So that's 25 minus 8, 17. Okay, so we've got that the cosine of x equals, and you're going to have to do the calculation twice, 5 plus the square root of 17 divided by 2, which is 4.56. Okay, what does that tell you? No solution, right? Cosine can't equal 4.56. So I'll try the other one. Cosine of x equals, this time we'll use the negative. And I'm getting 0.44. Okay, so let's see. If cosine of x equals 0.44, then x equals the cosine inverse. Second answer, 1.12. And let's see, if I look on the circle, again, this is 0, this is 1.57. 1.12 would be somewhere about like right there. Okay, now, where else, in what other quadrant would cosine have the same value? Somewhere. Quadrant 4. It's got to drop straight down, right? The x-coordinate is the same. It's to the right, it's to the right. But they said only between 0 and pi, so we're not interested in quadrant 4. We don't want either one of these two. We would only be interested if there was a value over here, and there's not. So it's 1.12, that's the answer. Okay, last slide. Right, solve in the interval 0 to 2 pi. Now, here we got two different trig functions, so how are we going to isolate them? No. And the answer is you're not. You're going to have to do something to make these all the same trig function. So any ideas what we might do that would lead us there? So what you do is you're going to square both sides. Right? If I square both sides, on the left I'll have the FOIL, right? 1 plus 2 cosine x plus cosine squared. On the right I'll have sine squared. But I have a substitution for sine squared. I can turn sine squareds into cosine squareds, and then it's all the same thing. So let's do that. So when you get something like this, square both sides. And now I've got 1 plus 2 cosine x plus cosine squared x equals, and sine squared equals 1 minus cosine squared. So at least it's all the same trig function, okay? Looks like it's a quadratic type or quadratic form, so I should get everything on one side, 0 on the other, right? So I'm going to subtract 1, add cosine squared, add cosine squared. And the 1's cancel, so now I've got 2 cosine x plus 2 cosine squared x equals 0. And that is factorable. Take out a 2 cosine x, and then I've got 1 plus cosine x. So either cosine x equals 0, or cosine x equals -1. Okay, so on the unit circle, where does cosine x equal 0? Where is the x coordinate equal to 0? Pi over 2, 3 pi over 2. X equals pi over 2, 3 pi over 2. Okay, where does cosine equal -1? At pi, right there. X equals pi. And that's it. So those are the answers all together. And we're done. So it's going to be these, and then I'm going to give you these 5 quiz questions that you should just do for homework, and then we could answer questions on them next time. Never mind.